I'm going to go ahead and do the computer. All right, welcome everybody. This is the TensorFlow Workshop. Welcome to kind of the what we could do with IoT Hackday here. Unfortunately, we did have to cancel the project track. We just didn't get enough people that were involved in that, and everybody that had submitted largely kind of submitted already completed projects, and it just didn't really make sense to have that event happen if we weren't going to get much done during the 2 weeks, and we didn't have any local teams either. So hopefully next year we'll be able to do that again. IoT Hackday is one of my favorite events every year, and it was a little bummed that we couldn't make that happen on the project track virtually, but I think in person it's been one of my favorite hackathons to attend. So next year, keep an eye out around Halloween, and hopefully we'll be able to do that again in person. So as to do something in place of that, we've got this TensorFlow Workshop, and just a little bit about the agenda for today. We're going to talk about TensorFlow, introduce all of you to that, talk a little bit about machine learning, and then we're going to dive into looking at a little bit of code. We won't be writing too much code today. Part 2 of this workshop is in a week from today, and if you're available to attend that, that might be just a little bit more coding than this one. And that's going to be kind of taking what we've put together in this workshop and then bringing it, instead of doing mostly client-side development, we talk about how you can implement that on the server. So I'm going to share my screen so that you can kind of take a look at what we're going through here. All right. Share. All right. Just a little bit also about me. My name is Chris Black. I've been doing software development now, since I think about 2006, 2007, working professionally doing both web and mobile application development. I also really enjoy speaking at conferences and teaching. I spent a couple of years teaching at Prime Digital Academy, where I was a full stack instructor teaching about the React, Node, and then you're talking about databases, SQL, Postgres, and for a while we were doing a little bit of MongoDB as well. Really interested in pretty much all things related to technology, whether that's the Internet of Things and building physical devices that solve real-world problems that connect back to software in some way. Last year at IoT Hackday, I worked with my friend Rob to help build a mouse that could be controlled by moving around your head, and it had a sip and puff that you could, it was a pressure sensor that you could use to right click and left click on the mouse. And so it allowed him to control a mouse without needing the movement of his hand. My friend Rob is a quadriplegic, and so he basically wanted to have a device that allowed him to interact with or control a computer without needing to physically have to move and click, which a lot of the input devices out there today kind of require that. So that's what we built last year at IoT Hackday. We've since then kind of worked on the project a bit, but still haven't quite gotten it to a point where we'd eventually like to get it to a point where it could be open sourced and 3D printed and built by anyone. I think we're getting pretty close, but aren't quite there yet. I also enjoy doing basically virtual reality, and I co-founded a Minneapolis-based virtual reality meetup, and that's something that we've been kind of meeting intermittently and talking about the different areas in that as well. And then today, talking a little bit about machine learning and that aspect of technology as well. So this is such a up and coming and growing field in terms of being able to use different models that are created to help do kind of real-time processing and more easily validate or solve problems without needing as much human interaction. And so you can think of, especially with all of the driver assist or the idea that we have cars that could potentially eventually be kind of driving themselves or being able to make decisions, and that's that part of machine learning is we're not going to build a self-driving car in to our workshop. But that application of being able to build something that's going to be able to make decisions and get input and understand its surroundings or environment is, again, really big up and coming field. So yeah, about me. Did the background, teaching, all the stuff I'm interested in. And today we're going to talk about TensorFlow. So normally I do a lot of my development on a Mac computer, but given the recording this and also running all the code and doing all the things at once, sometimes my MacBook struggles a little bit to keep up with all the software going at the same time. So doing this on my PC, which is a little bit more powerful, but at the same time, hopefully won't run into any hiccups into the development side of things, but definitely not a little bit outside of my my normal operation here. So what we're going to be doing today is going through the code on this GitHub that I've shared in the. I'm going to go ahead and just share this one more time and send this to everyone in the meeting. There's also a link to this on the DevPost page. But what you'll want to do is at some point here, probably fork and clone this repository so that you can make changes to it and commit that code. This is what we're going to be kind of walking through top to bottom. And then at the end, we'll have a few things that we'd like everybody to try working on throughout the week. And then next week, we'll kind of regroup and do part 2 of this workshop where we'll answer some questions, talk about where everybody got to, and then talk about kind of next steps and moving some of this code over to the server. All right, so this is definitely an intro to TensorFlow. So wanted to kind of start by just talking about what TensorFlow is and what we're going to be doing with it. So from the TensorFlow website here, the TensorFlow is an end-to-end open source platform for machine learning. And if you go to the TensorFlow website, you're going to find just tons of stuff that this library can do and lots of different applications for TensorFlow. TensorFlow can run on many different devices. We can have this running on a Raspberry Pi. We can have this running in our browser. We can have this running on in a computer, and it has lots of different applications for where you can deploy it and what you can do with it. What we're going to be talking about today is the image classification portion of TensorFlow. But if you scroll through here, you can learn a lot more about different applications. There are a lot of training resources available, and there are a lot of examples as well. So if you wanted to go take a look at different TensorFlow examples, I feel like their website, here we go, see demos. Sometimes when I'm navigating around the website, it definitely, there's so much here that sometimes it's hard to get to what I'm looking for in terms of the examples. And so if you find that is the case, you're not alone. Sometimes I have to dig around for a few minutes just to find something that I know exists somewhere on this website. Well, some of the demos that I think are really cool are being able to, in this case, move mirror, where some of the models that people have created are able to detect facial expressions or different body poses, being able to map, someone dancing on a, video camera to some avatar in 3D space. And I think that has really cool applications in terms of, augmented reality or virtual reality, being able to, map somebody's movement and what they're doing a little bit more closely than just, right now in virtual reality, often you just see, you get hands and you get kind of where someone's face is. But if you could somehow combine, body position and movement, I think you could get much more fine-tuned expressions and or avatars that more closely match to what somebody was actually doing in their living room, which I think would be cool. TensorFlow can also take in, audio. It can take in text, it can take in images or video. Really, the sky's the limit in terms of kind of what your input is into TensorFlow. And then ultimately what we're going to do is decide, what to do with that input, what kind of decisions we want to be making. And then once we have a model that's trained, it's going to take in that input and then spit out some output for us. And that output for us is going to be whether or not someone's going to be wearing a face mask. But you're all welcome to, take this and run with it and build an image classification that is something that interests you. So you're welcome to do the face mask portion of it. You're also welcome to, implement some other image classification that you find interesting as well. So if you're interested in learning more about the various applications and demos of TensorFlow, you can definitely go here and check out all the resources for learning. Let's see, back to this. So what we're going to be doing in terms of the model that we're building is we're going to talk about supervised learning. And so what that means is that what we're going to be building is, we're going to take a bunch of photos and we're going to use TensorFlow's kind of image classification to basically take all those photos and we're going to be the subject matter experts and we're going to classify those photos. So the idea is that, as we go through this, we're going to say, here's a photo of me wearing a mask. Here's a photo of me not wearing a mask, and take a whole bunch of those and we're going to classify those and then basically hit train. And we're going to use a pre-existing model that's going to go through all of those photos and it's going to do a whole bunch of mathematical calculations and detection and say, like what are the patterns and commonalities between all of the photos that we put into one bucket versus another bucket. And then it's going to spit out at the end its kind of prediction model that we're going to download and load into our JavaScript application. And the really cool thing about the prediction model, and something I want to explore a little bit more, or somebody with more TensorFlow experience could maybe shed some light on, is that when I just did the experiment with 10 photos, the output or the model that was generated was the same output size. The zip file is the same size as when I did the same image classification with 50 or 60 photos. And so what's ultimately happening here is, as it's processing through all of these photos, the output or the model that gets generated is mathematically based. And so at this point, I'm not going to talk to how that model gets created or the math behind that. But the idea is that it's going to do all of the processing and spit something out that no longer needs those photos to make decisions. So we don't have to have all of the photos we took. Once we have the model that we've created, that's the output. That's what's going to be used. But we don't have to store hundreds or thousands of photos and keep them indefinitely within that. And so by using supervised learning, we can kind of pre-train the model. The downside to this is that by doing it the way we're doing it, our model isn't necessarily going to get smarter over time. And so there are other methodologies with machine learning where you can, over time, you can train the model more precisely and say, you made the right decision or you made the wrong decision. So that's an alternate way of teaching or using machine learning, where you're kind of basically taking input over time and kind of doing a positive or negative feedback loop back into that to train slowly over a period of time. And so depending on the application, depending on what you're building, you may want to explore different models or different ways of utilizing TensorFlow. And I do think that the face mask versus not wearing a face mask is a very predefined problem set that will work really well for supervised learning. All right. So I know that was kind of a lot there. One thing to keep in mind too is the results of this. will depend greatly on the quality and quantity of the input you provide, right? And if I'm taking a bunch of photos of myself and feeding them into this machine, and then all of you go test this, right? The odds are it's probably going to be a lot more accurate in detecting whether I personally am wearing a face mask instead of, general population wearing a face mask, because I'm the one who trained the model using only photos of me. And that's something to keep in mind, is that the larger quantity and different quality of photos that you can provide as an input will train the model a lot better if you have a broader set of input that you're using to train your model. So what we would want to do if we're building a production application is get input from many different types of users, different ages, different genders, different races, everybody together, put that in there, and then you're going to have a much more diverse image classification model that's going to be able to make better decisions. But even with that, it's still important to keep in mind that just because the machine is doing making the decisions doesn't mean that we've removed bias, right? The images that we put into the machine, the classification that we put on all of those images can still have bias. And at the end of the day, it's really important to have a set of images you're going to use to help validate that your machine learning model is making the right decisions in all cases. So you still want to have a human element of this to be, you're checking and making sure that whatever model you create is still behaving the way you want it to, and that you'll still have false positives along the way. So any questions generally about, I guess, high level supervised learning and TensorFlow? I think the supervised learning will start to make more sense as we dig into like actually training a model.
Hey, Chris, this isn't so much a comment, or a question than just a comment. There are some interesting tricks you can do with skewing of images. So, while you might have a specific, like a small set of images, there's tricks you can do with filters to kind of skew them and angle them and stuff like that. So you can build up a larger set based on a smaller set, because oftentimes if you're looking at a mask, you might be turned to the side. So I just wanted to sort of bring that up, is even if you're limited on your data sets, there are some cool tricks that some of the TensorFlow tutorials talk about, that you can sort of increase your set just by doing some fancy things like that. Or I guess some creative ways to sort of, tweak the images a little bit.
Thank you. And another thing that I want to do a quick plug for at this point is the Applied AI meetup. So I can, Eric, if you want to post a link to that in the chat, a lot of topics similar to this are talked about at this meetup. And just at the last meetup, there was a talk about bias in artificial intelligence and how we can try to correct that. And it was a really interesting talk. A lot of it was actually kind of statistically and mathematically a bit over my head, just because it's been so long since I've taken stats in college. And it was interesting, though, to find out that once you kind of work towards removing one bias, you're introducing another one. And it's just like, it seemed like it was this, it was a really interesting way to kind of validate that your models are making the decisions that you want them to, and a super interesting talk. And so if you're interested in learning more about any of the topics related to artificial intelligence, machine learning, IoT, definitely check out Applied AI and attend those meetups.
Yeah, for those that might be listening and not seeing the chat, I guess in the future, since it's being recorded, it's just appliedai.mn.
Awesome, thank you. All right, so what I'm going to do is, the prerequisites, hopefully, if you don't have these installed, can get them installed either as we're going or over the lunch break when we kind of take a break for lunch. And then what I'm going to do is skip ahead to kind of what training a model looks like. And to do that, I'm going to have to stop my video and zoom, and then I should be able to go over here. So we've got a teachable model. And what we're going to do is we're going to gather some samples. And you can set up as many different classifications as you want, take as many pictures, upload, or using your webcam, and then ultimately train that model. So this, again, is a supervised learning. And what I'm going to do here is allow the camera. And just going to talk you through what I did for, so class 1 would be no mask. And take a bunch of pictures of myself. I can do, like Justin was saying, at different angles, right? Someone might not always be looking straight on at the camera. Again, you probably want a variety of different, backgrounds, or closer or further away, to give the best data that you can in order to make that decision. So again, the larger variety of photos, or having a diverse set of different photos with different properties and metrics will help with that. And then if we do class 2 with a face mask, right, and then I put on a face mask. And at this point too, as we're doing this, keep in mind that when the model is trained, that even things potentially like the type of mask that's being used, and how it's being worn, is going to make a really big difference in terms of training the model. So probably want to have different data sets with different types of face masks, potentially different styles at different, and again, having lots of different people wearing these as well would be helpful. This one. The other thing that I thought of when doing this the first time was, if we're just detecting mask versus no mask, the mask is really only, in terms of like whether someone's wearing a face mask, is really only going to be useful if it's worn correctly, right? So that I created, when I did this the first time around, and you'll see this in the demo and in the code that in GitHub, but I added a third classification for a partial mask or an incorrectly worn mask, because if you just have a binary no mask or face mask, an incorrectly worn mask is probably going to look a lot more like face mask, right? Like if you train a model and it's making a decision and it's deciding whether there's a mask, it's probably just going to look for there being a mask. But when I added that third classification for kind of a partial face mask, let's see. Now we're giving it data in terms of what to look for if it has a mask, but maybe we're wearing it incorrectly, or we have it just partially on, or just we're holding it, right? I don't know. Just thinking about how you would want to apply this towards input, and thinking about what's going to happen when we train this and what the output would be. And once we've trained this and we see the output, you can practice with it. It will allow you to preview before you export your model. You can preview that output. And the really cool thing about this is that if you're trying to validate that you did it right, and you're finding that are specific cases that it's just flat out wrong, right? You can go back and you can make some of those changes, and you can add a different classification. You can add different images to help validate and retrain the model. There are also some settings that I haven't gotten into here that allows you to adjust the model and potentially improve the accuracy of that. And right now, again, we're using kind of a out of the box model and training for this, where we're passing in images. We've used supervised learning, where we're going to tell it what each of the categories are. And then when we select train model, it's going to go through all of the images and now allow us to export the model, which we'll talk about here in a little bit. But what it's going to do is it's going to say, no mask. And then if we, right, just holding the mask, right, partial face mask or no mask, and detecting full face mask. So it's able to accurately detect, if I've got, right, like we've got it so that it's pretty well able to detect if I'm wearing the face mask correctly. And right, like that didn't take very long with the tools that they've got that Google has in place here with the Teachable machine. We can now export this model. We can load it into JavaScript, client side or server side, and use this in our web applications. So just to kind of take a step back, the face mask versus no face mask, may or may not have as many like applications in like across all industries or companies, but you can kind of take a step back and think about this in terms of, pause this, it's not flying around. If you were working for a utility company that required, people to take photos of the work that they did when they completed their job, like if they were replacing something or fixing something, and you're asking them to take a picture of the completed project, you could then detect whether or not someone's taking a picture of an electrical panel versus taking a picture of a concrete wall, right? Like you could potentially detect whether or not the picture is blurry. You could train your model to say, hey, it looks like whatever photo you submitted for this isn't what we were looking for. And I believe there are even some examples of like Airbnb was using this to classify images of, is this a kitchen? Is this a patio? Is this a living room? Is this the bedroom? Right? By training a model, you can now have image classification to help put things into buckets. And over time, somebody here is talking about mobile deposit on banking apps. Yeah, like, did you take a picture of a check or did you take a picture of your dog? Right? Like, whether or not you can actually upload that image, that's a great example of where a company might be able to save tons of time in having to have someone manually flag an image as like, this is out of focus, this is blurry, this is not a check, this is a blank check, this is, all of those things. You can train your model to detect those common mistakes. And now you could potentially be saving a team of people, thousands of hours of flagging checks. And then, if by the time you even get notified that your check was flagged, how many days has it been, right? And now you have to retake that photo, resubmit that. And if you were dependent on that check being cleared, to pay your bills this week, you want to know right away that check was out of focus. You don't want to wait for a person to be looking at that. You'd rather have something like this tell you right away, hey, I think your check's out of focus. Like you should retake this or double check this. And also the applications of this on a Raspberry Pi are really cool. If you're doing this real-time image classification, you could, you think about like Nest cameras and being able to detect, when a person delivers a package, right? Whether there's a package on your patio, being able to take these image classifications and talk about tons of real world applications for being able to do these detections. I think there's somebody, Daniel, one of the other members of the Applied AI meetup, was talking about teaching a machine to know whether the hot water heater was working by setting up a thermal camera and using that as an input and saying, well, I know what the hot water heater should look like as a thermal image when it's working. if it's not working, I want to know right away. So again, really, lots of different cool things that we can do with this as well. All right, so talked about the practical application. We talked about this. I'm going to show you a quick demo of what the code looks like that we're going to be building. All right, and I guess at this point, I'll pause again. Now that we've talked a little bit more about how we're going to be approaching this, any questions that have come up, either post them in the chat or examples of other ways of training besides the teachable machine. Yes. So what I'll do is, if it's okay, I'll probably, so the question is, can you give examples of other ways of training besides the teachable machine? And I will say yes, but we'll either do that as like a follow-up or push that more to next week, just because I don't have anything set up out of the box to do a different training. I will say that there are a lot of different models that people have built on GitHub that you can download and kind of use out of the box. But I don't have any examples of things that are quite as easy to use and as the teachable machine from Google. So there are definitely lots of different models, including if you really want to get into the math and more of the data science behind all of this, you can create your own model as well that interprets input and does something with that. And so again, like some people have created that facial expressions and different things where you can build on top of existing data models or just create your own. So I'll mark that as a follow-up question that I can post some examples for after the fact or next week. All right, looks like we've got a bunch of forks already for this workshop. The advantage of forking the repository on GitHub is that you'll be able to do commits and push your code to your own GitHub. By forking the repository, you'll have kind of your own copy of it, which is cool. And so you can definitely fork it and then clone it if you want to do commits. If you're not familiar with Git or you just want to tinker around in the code without having a GitHub account, you can just download a zip of the repository, and that will allow you to run the code like we're doing it here without having it tied in any way to GitHub. And so what you can do is if you fork the repository, I'm going to not do that because I'm already set up. I'm the one who created it. You can fork it and then clone it down to your computer, and you should be good to go there. So I've already downloaded the zip and extracted it, and I'm going to do clear. There we go. Clear. Oh, no. All right. I'm just going to create a new terminal window. All right, command prompt. Apparently clear is something specific to terminal. So what we can do is after you've downloaded that zip file and extracted it somewhere on your computer, you can then navigate to that folder. So we can change directory into the folder that has the code for the TensorFlow Workshop. And let's see here, TensorFlow. What I'm going to do is navigate to that folder on my computer. Right, and from there, inside of the folder, we can do an npm install. And so what this is going to do is it's going to install the dependencies for the workshop. And so we've got the code that we downloaded, navigated into the folder for that code, and then we typed npm install. This does require you to have Node and npm installed on your computer. There's a link to that within the GitHub instructions, as if you don't have that set up. We'll do a lunch break where people will have time to kind of get caught up if you don't already have Node installed. So once it installs everything that you need for this, the next thing we can do is type npm start. And I have already set up a really basic localhost server that will start up when we type npm start. So we'll talk a little bit about the code for that in just a minute. I just want to show you what this should look like once you're set up and have started. So now we're listening on port 5000. If you have anything else running on port 5000, you can only have one thing listening at once on a single port. So you will have to potentially, if you have another server running, you'll have to stop anything that's running on port 5000. But once we have that set up and we do the install and we do the start, when you go to localhost :5000, you should see a basic website pop up that just says TensorFlow Workshop IoT Hackday 2020 with a button that says start. And I'm going to press the start button. And at that point, you should see a web camera pop up. You might get a little notification here asking you to allow access to the web camera. Hit allow. And what this is doing is it's using my pre-trained model, and is the model that I already downloaded and checked in with this project. And it's using the web camera, and in real time, it's detecting whether or not it thinks I'm wearing a face mask. So there, it thinks I'm wearing a face mask. Here, no mask. I don't think I did quite as good of a job on this one of partial mask as I did maybe on the one we just created. And so what you can do with this is when we take a look at the code, you can very easily adjust this to match whatever type of image classification you want to do. So it doesn't have to be mask or no mask. But this is what it should look like when you type npm start. All right, so now let's take a look at the code behind this and talk about the different pieces of this, and then take another break for questions, and then potentially eat some lunch and or have everybody download this and start playing around with it themselves. So I'm going to open up this project using Visual Studio Code. Open folder. And this should be this PC, TensorFlow Workshop. Let's see, where is that? Downloads. Perfect. All right, so I'm gonna, in Visual Studio Code is kind of my editor of choice here. I'm going to open up the folder for the TensorFlow Workshop. And we'll take a look at some of the code. So the other thing that I really like about this example is that, if you go to the TensorFlow website, there's so many examples, and especially if you start going on to GitHub, some of the examples get really complicated really fast. And the goal with this example was to kind of provide a space where you can really get very quickly to something that does, like, I think the image classification is really cool, and it allows you to create a demo of being able to get up and running with TensorFlow very rapidly. And so what we've got here is the server JS is what sets up the server. So all that does is it runs on port 5000, or if we deploy this to Heroku, which we'll do in the second, we'll do after lunch, it will allow you to then deploy this out to hosting by using the port that's provided there, or on localhost, it will run on port 5000. We're using Node and Express to just spin up a really simple server that passes all of the files from the public folder to whatever localhost 5000 is when it's running. And then the app.listen is what kind of just kicks off that whole process. So this is all the code we need for the server portion of this. Again, in part 2 of this workshop, we'll talk a little bit more about how we can build this out and add to the server code so that we can do this image processing on server side instead of client. But right now, the majority of the code is going to be in our public folder or what's presented to the client. So on that side, we have our index.html, and that has our header, which is the TensorFlow Workshop, which will match directly to what we're saying here, TensorFlow Workshop. And then we've got our H3, and then our button to start, and then our web camera container, which is going to be the place where all of the, like that web camera appears, and then the label container, which is where those labels will appear. So again, fairly basic HTML. You're welcome to add some additional styling to this, make it look a little bit cooler, update the CSS. And then the majority of the code here is going to be in the client.js. And what's really slick is that most of this code was actually provided directly from the Teachable machine URL. So if we go back and we take a look at that in just a minute here, you'll see that it actually exports some HTML that you can copy and paste, and it will look a lot like what's set up here. So they provide a lot of that foundation just to get this up and running. What I've done here is added in jQuery just to clean it up a little bit and simplify things. And when the document loads up, what it does is it looks for the model that was predefined. And the model that I've used for this is the demo image model, which we have here in this folder. So these are the files that you'll replace when you create your own Teachable machine model. And then it looks and it loads up the metadata and the model for that. And the max predictions are the number of, in our case would be 3, mask, no mask, partial mask. And then when we click the start button, it initiates everything, which starts up the web camera. It sets that up and then starts playing that. And then we'll loop over, constantly checking the web camera and taking the current image of the web camera and passing it into the model to predict. So once the init only runs the one time and it sets everything up, it adds the web camera, it adds the labels, and then as we go through the loop, which is happening just continuously on the page, it's updating the web camera, awaiting the prediction, and then basically requesting the next animation frame, which loops again. So it's just constantly going back over this. And the prediction, just to kind of walk through this, because this is the most important piece of this here, is that we're asking our model to predict, we can pass in image, video, canvas, and we're awaiting the prediction to come back. And then what ends up happening is that the prediction is going to be an array of objects that will have, what it is. So mask, no mask, all of that's built into the model, and the probability that prediction is accurate. So the prediction the class name here is going to match whatever we defined when we created the model inside the Teachable machine. So we don't have to set any of that here. That comes from the model that we created. And then the probability is that that number that appears right afterwards. And then what I did here is I said, if the probability is greater than 1 over the max predictions, which means the likelihood is, in this case, greater than 33%, I highlighted it red, just to kind of show which of the predictions it seemed to think was the highest. And so you can adjust that based on kind of what you want to do. But then it was going through each of those labels and updating the prediction to include that information. So Again, really, I think a fairly straightforward implementation, but does something really cool. And so we've got kind of going top to bottom again. The key steps here are to get it up and running. Really interested to see if it works for you, detecting mask or no mask. And then once you've got that set up, you can go to the Teachable machine, train your own model. Once it works the way you want it to, you can export. And we want to export to TensorFlow JS. If you are trying to get this onto a Raspberry Pi or something else, you can do TensorFlow Lite or some of the other options in terms of getting this onto other devices. We're going to use the TensorFlow JS, and we're going to download the model. So I could take a screenshot of this too and post this. But once you have what you want, TensorFlow JS, download the model, and then this is where it's going to show you that JavaScript. And this is what I used as a starting point, where it's going to do the initialization, it's going to do the loop, and it's going to do the prediction. And right now, you can ignore this JavaScript output because it's effectively, this is the same thing that you're or close to what we already have in the project. What you want to do is download the model, which will download here. And let's see, I'm going to bring that over to okay. So then once you have that, you can right click and we can extract all. And once you've extracted that model that we just downloaded from the Teachable machine, it's going to give you the metadata, the JSON, and then a bin file. And then you'll take these three files and either replace what's in the demo image model, or you can just upload it as a separate, or I'm sorry, not upload, copy it as a separate folder within the public folder. If you want to, instead of replace, just add to, and then you can set the URL to your new model. So what we can do here is we can bring that over, we can copy it into the public folder, and what we'll do here is I'm going to go to the downloads, and I'm going to copy that into the public folder. So this was the model that I just created, Teachable machine. If we copy that and then paste it here, it's now going to use that model instead of the one that was there before. And if we make changes within the public folder, we can just refresh the page and they'll immediately be applied. If you ever make any changes to the server folder or the server file, you'll need to restart the server by hitting Control C and then typing Npm Start again. But if we go back to the browser after copying in those new files and updating this path, going to localhost, I guess in retrospect, doing something different than mask, no mask. It did update here, partial face mask, which is I used a little bit different wording there. We can see here that this one's not as accurate as the one was before because it thinks I'm partial face mask is there, and then yeah, this model that I just created had way fewer images than the one that I had before, so it's definitely not looking quite as accurate. But that's the general idea, and you can do this with whether you're holding a coffee cup, whether it's a picture of a dog or a cat. Definitely feel free to take kind of creative liberty in teaching the machine to learn something that's interesting to you. And I want to kind of break here for kind of two things, do some more Q&A, and then we'll do some lunch and give everybody some time to kind of go through these steps, which are outlined in the, so if you weren't coding along with that, the steps here in training a model gives you everything that we just went through in order to change that and set that up. So that's kind of where I'd like everybody to go through and just practice with this, create a teachable machine, and then see if you can get it to learn something. And then after lunch, we'll talk about additional considerations and deployment. So let's take a short break here for questions and then for some lunch. How do I know if the local host has switched over to the new model? Yes. So you'll know that it's switched over to the new model if you name your image classification something, just slightly different. So you might want to name your image classification if you're going to do the face mask piece of it. Not wearing a mask instead of no mask. Just something just a little bit different in terms of text for the classifications. Or if you want to do something different that's not face mask or no face mask, then you can also know whether or not you switched over, because it will say those new classifications below the web camera image. And so that's how you'll know that you've loaded up a different model. So another question, what actions can you take to make the model more accurate beside using more input during the teaching phase? Yes, so, having a variety of different input types is key. As Justin was saying, there are ways to potentially skew or manipulate images to use fewer images to provide more information. And the settings as well, when you do the teachable machine, I'd start by just using the default settings, but there are options within the teachable machine that the epochs and batch size that can be adjusted. And what I'll do is I'll take a look at that and try to have a better answer for that after lunch. Right now, I'm not specifically sure on kind of what those are going to do. My guess is that the epochs is just going to take a lot longer if you increase that number in terms of the training. The information on that is that by increasing that number, you'll get a better results. So I'm guessing that that will mean that your training will take a little bit longer. But I also have not done any of the under the hood settings as well, which look interesting too. So I think that would be something that we can talk a little bit more in detail about maybe next week or after lunch, in terms of how we can improve the quality of the model that we're training. I guess, Justin, do you have any other tips or tricks on improving the teachable machine?
Am I unmuted here?
Yep, you're good.
Oh, good. Yeah, no. I mean, a lot of times when there's data sets that you download off of the internet or stuff like that, they've done some of these skewing. They've flipped things. They've rotated. Because oftentimes you're not going to basically be able to see these images in certain ways just straight on. The epoch stuff is interesting, and other people that maybe have delved into some of the TensorFlow image manipulation as well. It will converge to a good amount with regards to the percentages that it finds, but at some point it either will diverge, and I've seen that, where it starts picking up other things outside of your face, outside of the image, and it starts honing in on, hey, Chris, you have a curtain up over there. Well, that means that it's probably not a mask thing, right? It starts looking at other things outside of the frame that are actually false positives. And so what you're trying to do is you're trying to get it to a certain point where it's the best that it possibly can, but it's no better. And like you mentioned, it would take a lot longer to generate the model if you're running if you're running 1,000 epochs or whatever, instead of just a handful of them. And then, like I say, it can actually be detrimental at some point. Oftentimes what they try and do is actually isolate, the background. So, when you're using when you're doing the teachable machine, your training set is actually the entire image, right, Chris? It's not just your face. And so if I were to take you and put you out in the wild, you're actually going to see probably worse things. That would be fun. That would be a fun experiment where you trained it with this certain, lighting, certain background, certain shirt that you're wearing. And then, try it tomorrow when you're not wearing that same shirt. Try it when you're in a different room in the house and see how good it is going to be, because there are other things in the image that have not been isolated. So ideally, you would actually want to strip all those out and literally just have your face on, say, a white background, or actually only have it be learning within a certain number of pixels within the screen. So if you see some of the other examples, they're like, hey, I want to find a dog versus a cat. Well, those are just focused on just the dog and the cat, and really looking for those types of pixels. And I guess the other thing too is a lot of times these images, and I guess I don't know exactly what Deep Machine's doing I keep saying Deep Machine, but what the system is doing, the Teachable is doing under the covers, but oftentimes they'll remove the color layer. You don't really care about the colors. You really care about the pixel, the gradient in grayscale with these images. So little tricks like that. I guess if you were to build your own model, these are things you're going to have to do. You're going to have to manually run into and sort of build your own image sets that take all these other things into consideration. So it's great that Teachable Machine does that for us really quickly, but you can unfortunately tune the wrong parameters sometimes that will actually end up causing you to get worse errors than you would possibly think.
Thank you. And I would completely agree that the Teachable Machine is great for certain applications. Especially I think with the check, taking a picture of a check is a good one, where the parameters on that are so fixed that it's fairly, I think, straightforward to teach something where it's you're detecting sharpness and shape. But yes, I would agree that like the face mask, no face mask, if we were to actually go deploy this to a place of business or a restaurant, we would probably want to tweak the model or create our own image classification model that was fine-tuned for the specific application that could do face detection or oval detection, and then focus on that for the face mask. Because you're right now with image classification, it's just taking the whole image, and it would be really hard to that point get a production app where the background could be different and there could be so many different things that you'd really want to train a model that was able to focus in on just someone's face. And so this is, I think, a really great starting point and a really great entry into machine learning. But you would, if you're interested, maybe want to dive in a little bit more in the creating a model.
Yeah. Go ahead, Yanni. I was going to say you probably have an input on this.
Yeah. So I second everything Justin and Chris said. In particular, the epoch parameter would have a sweet spot, and not just because of time of computation, but also because of overfitting. So if you make epochs too long, you might, just like Justin described, you could get into overfitting where irrelevant elements of the data are being memorized instead of being generalized. So in a state-of-the-art development environment, we'll have a holdout set where we don't use that for training. And the only thing we're using the holdout set is, and we call it a validation set, is to figure out when we should stop training. So you don't have to pick epochs, because you'll be using that holdout set to figure out when is it time to stop training. So that's what you get when you do this kind of things, with full force instead of, simplified example. But this is awesome. I mean, the JavaScript here, like, it's so easy to get a model. Like I had an idea for a long time that I wanted to do like something that measures my daughter, how many hours is she practicing the piano. And this Teachable machine allows me to implement this in like, I don't know, 15 minutes. That's just blows my mind. Anyway.
Just by training on sound, right? So
just by training on sound, because they have an option. They have an option also to do the same thing with sound, and I'm playing around with it as we speak. So
right.
So this was awesome. Yeah.
Yeah. No, it's an awesome thing that Google's put out, because it kind of like lowers the barrier to entry with anybody that has a browser and a camera and a microphone to start throwing data through the system. And like you say, it's not foolproof, but it's a great starting place. And then the beauty of it is that then you can just export the model and you can take it and do it wherever you want. You want to put it on a Raspberry Pi, you want to put it on your phone. I mean, you can go ahead and put these models using TensorFlow Lite. You can go ahead and put these models on your iPhone, your Android phone, and you can start taking these models with you. Just even
right on an Arduino that makes an alarm if you take off the mask.
Right. I think the thought experiment that I kind of go down is this is all supervised, right? So that's the thing, is that we're trying to feed it as many pictures so it learns what it's like. But is there an unsupervised path at some point where you were to feed it enough just images irrelevant of what it is, and the system can actually realize over time that these two are not the same? So can I classify it myself, right? And I don't know where that leads to, but it's the whole idea that right now is that where you have to feed it thousands of images, or like, I mean, a handful in your case, but in harder problems like this, you may not have enough data, or actually have the time and effort to classify them, right? Or you have so many different types of variations. For us, we basically classified it in on or off, right? We classified it with there's a mask on or there's not a mask. Well, that's a pretty easy thing for a human to do and go through and select some things. But what if the feature set is hundreds and hundreds of different things, and you wanted to say, not wearing a mask and in a restaurant, or not wearing a mask and it's nighttime, and you could build all these things out and be very, very hard, or be very, very time consuming for humans to try and classify these. And so then you start dealing in the areas of, well, could we create an unsupervised learning system that would then start to classify these things for us based on the data that we get?
And that's exactly what variational autoencoders do. So that's what I said is my obsession. So, yeah.
Yeah, so they deal with problems where humans couldn't even go through the classification of them. There's just too many features.
Well, you don't know what you're looking for, actually.
Don't know what you're looking for. Yeah, sure. That's a good way to put it.
All right. So one more question before we take our lunch break here. If we train with photos instead of the webcam, the photos need to be cropped to the same proportions and dimensions. I don't believe that they have to all be the same dimensions, but I did run into an issue where taking like a screenshot on my computer was problematic in terms of, I don't think it had the right metadata in the photo, or something was off. And so if you are using photos, I would maybe save them down from your phone, or Google for them. Or if you're having issues with photos, let me know and we could kind of dig into that. But I did have some issues with photos if I took them as like screenshots on a Mac. Didn't always work the way I thought they would. But otherwise, it should be looking for the mathematical like signatures. It should be relevant of actual proportions of the image.
Typically, they just get rescaled to
right.
the proportion that was used in training. So,
all right.
The networks themselves that do the computation are highly reliant on a particular resolution and a particular proportion. So the network itself would not be able to adjust.
Right.
It's the picture that gets adjusted before it's fed in.
Yeah, you need to do that scaling on your own, and if you train images at a 16 by 16 pixel or whatever it is, then you should then do predictions with those types of things or scale them down.
So I'm actually going to go grab some lunch here. We went a little bit past our scheduled like lunch break per se, but I think it's great. I mean, these conversations are exactly what I was hoping to have, and anybody else that has input or questions, this is great. We got through most of what I wanted to get through in terms of the application side of it, and then we'll talk briefly about deployment after lunch, and then really kind of open it back up to any other questions or experiences that people have when they set this up. So let's take another 20 minutes here to just let's meet back at 12:30 and kind of wrap this up and talk about next steps and kind of the plan for next week. But yeah, I'm gonna go grab some food real quick.
Super, Chris. Thank you so much. Meet you back.
Yeah, definitely.
All right, welcome back. I paused the video recording over lunch just so there wasn't too big of a gap there. I wanted to start by showing something that was pretty cool. I just posted a link to some other TensorFlow models that can be used for different things. And one of the ones that looked really interesting was the body pose. And I'm going to show what that looks like. Here. Whoa. So this demo looks really interesting, where it will detect I think it's getting the eyes, nose, and ears as well as like my arms. Probably work a lot better if I backed off quite a bit. I think it's picking up the chair a little bit there. But it's basically kind of detecting where my shoulders are, hands, and that's really cool. Running pretty fast too. So this is just one of the examples that was posted, or I linked to directly from the TensorFlow examples. But just the idea that, we're using a pretty basic example with the Teachable machine and learning from images, but there are additional TensorFlow models that can be used to do all sorts of different types of things. And it would be really cool to like tinker around with some of this, because honestly, the JavaScript here, I mean, when you're loading and using an existing model, right, you're basically just taking in their JavaScript, and then you can do what you want with it from there. So code for this, the one I just showed you, super simple to get up and running. All right. So with that, I think a couple of things to note. I know that a number of you might have been eating lunch instead of diving into the code, which is totally fine. I did set this up in such a way that, that gap between the two workshops. So we're going to be doing another one next Saturday. If you can't attend the workshop next Saturday, I plan to record that one as well. The other thing to note is that if you were only able to attend this workshop, like there's a pretty clean breakpoint where you're going to have the week to tinker around with this code example and try to make it your own. If you have any questions, if anything comes up during the week and you can't get something to work, feel free to email me directly. We'll also maybe try to set up some sort of a chat interface, whether through Discord or Slack or something, that we'll send out to everyone if you have any questions. And then next week we'll answer some questions as well. So if you didn't have time over lunch to get everything up and running, that's totally fine as well. So I guess for those of you that did have a chance to tinker around over lunch, would love to hear a couple people just talk about their experience with how it worked, or if you have any questions. I did also have a few discussion points as well to talk about, just in terms of, as you go through this, the considerations for the models that you create and, understanding what limitations and gaps those might have. So I think at this point, I'd like to just open the floor to a couple people to just talk about their experiences and or ask some questions.
Chris, I've got a question just based on usability. So I didn't have a chance to set it up, but I'm looking forward to setting it up to kind of train if I'm holding a water glass or not. But obviously the processing load of this program is really high, so I couldn't implement that to actually keep track of it through the day. Is there any way to take it from loop to maybe check every 15 seconds and then do that same logic?
Definitely. Yeah, you can do that with either with the JavaScript version. You can just have it set up on a timer and read the web camera on a longer lag. Or if you were to set this up on a Raspberry Pi, you could do more of a time lapse and have it be every few seconds, doing that detection where you're offloading from your computer's processor to some Raspberry Pi or an alternate device that could do that as well. So definitely slow down the loop. Right now, the way that the code is written, it's my understanding that this loop here, requesting animation frame, is going to happen as fast as the computer can handle. And again, on my desktop computer, this is happening at really, really high frame rates. On my MacBook Pro, it was a little choppy, but still, at least 10 or 12 frames per second. And so it is running really fast for these examples, but you can definitely slow this down. And instead of this being a loop, you can do a timer interval and have it run every few seconds. It will also, if you use your desktop computer, potentially be taking over your web camera. I know on a Mac, I think the web camera can be shared across applications based on my testing. But on a PC, it's only letting me use the web camera either for Zoom or for these demos, which is why I keep turning it off when I switch back and forth. But if you, again, wanted to pick up a Raspberry Pi with a Pi camera and hook all that up and tinker on that side of things, you're also looking at a fairly minimal cost to get ramped up on that. And I do have actually Adafruit has a great tutorial on how to get TensorFlow Lite set up on a Raspberry Pi. The process is much more in depth than the JavaScript version. This is basically, source in the code and hit go and it works. The TensorFlow on a Raspberry Pi is a lot more in depth in terms of setup and installation, configuring your Pi camera, all the things. It takes a couple of hours, but it's still a really fun project and allows you to take this more portable or mobile.
Hey, Chris, this is Claudio. I got a chance to play with it, and it took me all of 2 minutes to implement. I thought it was, like I said in the chat, I'm kind of angry at myself for not discovering this sooner, because I'm excited to kind of implement it. I guess one little observation or question I had is, it was giving me 100% confidence on mask or no mask. And that, at first I was like, oh no, it doesn't work. It says I'm not wearing a mask with 100% confidence. I put the mask on and it said mask, 100% confidence. And so I couldn't help but feel like I did something wrong. But is that just because I trained it with 300 images, or is there a setting, can you tweak that confidence level? I guess I'm having trouble formulating the question, but so it's more of an observation, I guess.
Yeah, I'd actually be really interested to know what confidence level it is on partial mask, or if you were to cover up your mouth with your elbow and see if you can get it to if it was always binary 100% only one or the other, even in some of those edge cases, I'd be concerned. But if you train the model with enough images, I would say that it probably is able to detect at a very high probability. But again, that's probably just for you, not necessarily for for like if I were to use your model, and the one that I trained probably doesn't work with 100% confidence on you.
Right.
But that is really interesting. I was able to get it for me at either 99 or 100% as well on the one that I gave a ton of images to. Anybody else that was able to get this set up and has any thoughts or questions?
I had a thought. I was just curious how you would automate teaching this machine. You know, like how do you loop through a bunch of images and associate them with a category?
Yeah, and I can post a link and some resources to that. There are ways to kind of train your model over time and add to it. And so, it's one of those things where if you get users to upload photos or like those CAPTCHA things, right, that you see online is like, is this a taxi? You can kind of use the responses from some people to then classify those images so that then that's training your model for others, if that makes sense. So you can train over time. The code that I provided does not include an example of that, but you are able to take images and classify them into buckets and build your model as well. And I'd have to look for the code to do that. That's an alternative approach, especially one that, like Justin was saying, you don't always have a complete data set up front, and sometimes you might want to train over time, and that is something you can do, but it would require a few changes to the code that we have. Other questions?
Okay, I've got one. So the Heroku Create command, I got as far as trying to deploy, or attempting to deploy to Heroku, but the Heroku Create command, there is no Heroku command. Do I need to install some command line tools for that to work?
Yes, actually, that is a perfect segue. Let's talk about that right now. And we can actually go as far as setting up the command line tools, because I have yet to do that on my PC. I've done everything else, set up Node and everything on the PC, but have not installed Heroku. So, and we'll have a little bit of time left over at the very end here for some additional Q&A. But I did want to talk about how to deploy this. So you've got your model that you've trained. It does something cool. You want to put it out in the web to just send a link to your friends or family, or just be able to access it from anywhere and test it out. Heroku it provides free hosting, and there are some limitations. And the other thing to note with Heroku is that if you're using their free hosting, it does take like sometimes 15 to 20 seconds for your website to boot up if you haven't accessed it in a while, because they put the free tier instances to sleep when they're not in use to save processing, which makes complete sense. So, if you want to use Heroku for free hosting, where you can, instead of viewing this on localhost, view it from anywhere in the world, you do need an account on Heroku, and you do need to install the command line tools in order to use that within either command prompt or terminal. So if you're on Mac OS, you can install via brew. If you're on Windows, you can install the corresponding command line tools here. So I'm going to go ahead and just run this and let that install. And then once this is installed, you will need to authenticate with Heroku and link it to your account the first time. So once this installs, we will do a Heroku login to log into that, and then we can type Heroku Create. The other thing to note with Heroku is that if you haven't provided a credit card with them, at least this is all as of about a year and a half ago when I last was using this and setting this up, it allows you to do like, I think 5 websites for free before it does require you to put in a credit card number just to validate that you're a real person. And then you can do as many free websites as you want with that, again, that limitation of that slow boot up time the first time you access it in a while. I've never been charged by Heroku on my card, but it's one of those things that they, capture like thing where they want to make sure that you're not abusing the service. So again, Heroku, free web hosting for Node and actually that variety of different web applications, but specifically it will work for running the one that we have. All right, so Heroku is installing still, and then we'll get that set up. The other thing to note is that if you did fork and clone this repository, I would definitely recommend going through and updating the README to include, picture of the application as you have it, or remove the image. And you're welcome to, add your own flavor to this and turn it into whatever you want to turn it into. And then the link that I have to my Heroku running this right now is this still temple. They create like a random name. If you want to rename this and give it your own name for the Heroku app, there's a way to do that in the settings as well. All right, so this is still going. So what we did here to get Heroku up and running, if you haven't already installed Heroku command line tools, you can go to the, you can Google Heroku CLI or Heroku command line tools, and you should get this page that allows you to download and install those tools. From there, we should be able to then type Heroku -- version, and then we'll do a Heroku login where we'll log in with our account that we created on Heroku. And then we can type Heroku Create from within our project folder, and it will create a hosting instance for us that we can push our app to. The only other requirement that Heroku has is that your project needs to be a Git repository. So if you downloaded the zip of the file, which I did here, you will need to initialize your repository as a Git repository. If you forked and cloned the repository, it's already a Git repository, so you should just be able to push to Heroku. All right, so that is complete. Let's see if it worked. So I'm going to first stop the server. Sure. All right. So then we're going to type Heroku -- version. All right. I believe I have to restart command prompt in order for that to pick up. All right. Terms of service have changed, but it does recognize Heroku as version 7.46.2. So if after you install it, you do need to close down command prompt or terminal, restart that, and for it to pick up on those changes. And then what we are going to need to do is navigate back to our project folder in order to, let's see, TensorFlow Workshop. All right, I'm going to do change directory and navigate to the workshop folder. All right, and then cd TensorFlow Workshop. So you need to be in the folder that has all of the, all the stuff in it. So you want to be in the folder that has the server.js and your git ignore, your kind of root project directory. And what I'm going to do first is if you just installed the command line tools, you need to type Heroku login, which is going to press any key to open the web browser to log in. Cool. Login. All right, I'm going to grab my credentials for that from LastPass, and I'm going to log in on my other screen here just to keep this secure. Okay, copy password. Okay, and I'm going to log in to Heroku. Okay, so it says I'm logged in, and now I can type Heroku Create. So what Heroku Create does is it creates an instance that we can deploy this application to. Before I type Heroku Create, because I did download this as a zip, I do need to initialize this as a Git repository. Because that's not the normal workflow, I'm going to do that off screen just as to not confuse people. Odds are you already have everything set up. If you type git remote -v, it's likely you're going to see a Git repository. Right now, it's saying this is not a Git repository because, again, I downloaded the zip instead of forking and cloning it. And so what I'm going to do is just initialize this as a Git repository. Okay, and then I'm going to do git add dot. All right, so I set up as a Git repository, and then if you made any changes to your code, you're going to have to type git. You're going to have to add those changes and then commit them. So I'm going to type git add dot, and then I'm going to, oh boy. I'm actually going to open up a new command prompt. I don't know where all this white space came from. Try this one more time. Okay, and then I'm going to do git remote, all right, git add dot. Okay, we added all the files. Git commit -m and say initial commit. Okay, so this has to be a Git repository in order to deploy to Heroku. And so now that it's a Git repository, I have set up the Heroku command line tools. I can type Heroku create. And what that will do is it will take and it created a murmuring tundra for us. So it just creates a random prefix or subdomain for their on Heroku app. And then what I can do is type git push Heroku master. And what that will do is it will push to the branch. Some ref spec does not match any. Git remote -v. Give me just 1 second here. Failed to push some ref. Git branch. Aha! I set up Git. The new I just installed Git and it gave me the option of setting the default branch as main instead of master, which is a change that they are implementing over time. And so I checked the box to be just to do that sooner than later. So the branch that it created, because I created a new GitHub repository, was main. odds are your main repository is either, your main branch is either going to be called main or master. In this case, I'm going to need to do a git push Heroku main to push the main branch to Heroku. Okay. So pushing the code, I created a Git repository. If you don't already have one, you need to create one. Set up the Heroku command line tools. Once this is all set up, when you do a new project, all you have to do is type Heroku Create and then commit your code and then do a Git push Heroku main or Heroku master, depending on what your main branch is. And what that will do is it will send everything up to Heroku. Heroku will run an npm install. It will then run npm start. And once it does all of the things, so it installed all of the dependencies and all of the packages, and then it deploys it to the URL that it created. And this usually takes like about 30 seconds. So I only do deployments when all of the code localhost is working the way I want it to. And once that's been deployed, you can do Heroku open, or you can just copy this URL and paste it in your browser. This is the your website now. And if I type Heroku open, it will open that up. You can see here that it's the murmuring tundra, which matches that URL there. And it's going to look a lot like what we just did here. And so what I'm going to do is stop my video on Zoom so I can do this. Allow. And this should have, there it is. Again, this was the one that I trained that was partial face mask, and this one didn't work nearly as well as the one that I done with a larger image set. But it does pick up, if I remember correctly, full face mask and partial. For some reason, my no mask pictures must not have been very good. There you go. If I tip my head back in the right direction, it gets no mask. But you can see that how you train the images, or how you classify and what you use for training, makes a big difference in the quality there. But this is now deployed. I could share this URL with whoever and check this out. Again, next week, so we'll do part 2 of this workshop next week for those that are interested in diving in a little bit more onto the server-side development. So just some downsides and upsides to this running on the client. The upside to this running on the client is that you're doing all of this real-time processing on the client computer without using any server resources. The downside to that is that you're providing your learning model files publicly to whoever goes to this website. So if I go to the inspect, I'm likely going to be able to look at the sources and potentially find access to like where my image model is here, and then be able to do a directory listing and find that. So for this case, for this example, I don't really care if someone finds the image model and where is it, metadata.json. Where did that just go? Oh, it probably opened in here. Metadata.json. There we go. So by putting the model in our public folder, we are making the model that we created technically publicly available to whoever goes to the site, because it's loading up on the client. It's going to have the labels. It's going to have all this information. Someone could download the bin. It's publicly available. Technically, if you deploy to Heroku and you put it in the public folder, it's going to be available. If you had some proprietary, algorithm you had, or had a proprietary model that you didn't want to make available, you could implement it on the server, and that's likely what the bank check processing does. They probably don't want you to know, what they're looking for, or the specific code they're running to determine whether or not it's a valid check. And so it's very possible that you're going to want to put your model on the server, which is going to be protected from, users being able to just arbitrarily find these files and open them up. And so if you did want to have image processing where a user is going to upload a photo and you're going to give it a pass or a fail, you could upload the photo, have the server running TensorFlow JS, run that image through your model, and then spit back a pass fail. Or, another common example of that would be the image, like object detection within an image. So Google also has a library or a model that will, you give it an image and it tells you what it thinks is in that image. And so there are a lot of different applications where this could be useful running on the server as well. So that's more on that next week if you're interested. But for this week, just to recap what we did, we used TensorFlow JS and the Teachable machine to create our custom trained image classification model. We then loaded that into our JavaScript application and booted that up. And then displayed that on the web page where we're taking the input from the web camera and passing it through the model that we created and make predictions about different classifications. And really the core piece of this code here is this, this model.predict, which we're using, and we can pass in an image or canvas, video, whatever we want to do in order to make that prediction, or audio or text. There are a lot of different models out there that we could utilize. I think one of the other popular examples is like determining whether or not a comment is written by a robot or is spam. And while the robots and people writing spam constantly get better and better, having these models that can help predict based on how copy is written, whether or not it's spam, is also an interesting application of machine learning. All right, so we kind of hit the 1 o'clock timeline here, but definitely open to it staying online a little bit longer for some Q&A. I do have a wedding that a socially distant wedding that I am attending that I need to be at like 3:30, so I'm not going to be able to just hang out all day. But I've got at least another half hour that we can do some Q&A, and then we'll be checking my email and would be more than happy to set up 15-minute screen share video calls if anybody's like struggling to get this set up and just needs a little bit more guidance. And hopefully all of you will be able to attend next week to dive in a little bit more on the server side. Where will we share the recorded video? I'll send out a recap and a link to the whole group. My intent, I'm going to run it by the Applied AI group to determine the destination. I think I'd be inclined to just post it on my YouTube, but if they have a more centralized location that they prefer to have it, either way, I'll send you a link and recap after the workshop. So within the next couple of days, probably by end of day Monday, expect to get an email with the link to the video.
Yeah, I'll just interject real quick. We do have, Applied AI does have a YouTube channel as well. So whether it's on yours or it's on ours or both, that would be great. I think it would be good for us to cross post it.
Cool. Any other?
Can you tell, like in terms of the JavaScript that we're saying here, what's the learning path to be able to read all of this code and understand what it's doing?
Yeah, let's see. So I could send out some resources on kind of getting started with JavaScript. This is using a couple of newer features with the async function, so it's using the newer version of JavaScript, which should work in all modern browsers, but isn't going to. You'd have to run it through like a Babel or something to get it to be backwards compatible with older browsers. I'll send out some resources. I used jQuery to help simplify the init and setup a little bit, and would be happy to answer any specific questions. but yeah, I think that this example is fairly light on JavaScript, and so I think that I can send you some resources that would be kind of a intro to JavaScript that should get you going on that.
Super.
Question for the group here. So we started the workshop today at 10:30. So was that a good time to start for? Was that a good time? And for the workshop next week, what are people thinking? 10:30? 10:30, 10 o'clock?
For me, that was good.
Okay. Go ahead.
Yeah, and we start. I think it's good to start the Zoom call a little early for people to get kind of set up and logged in. But I think the plan would still be to let's see, what did we say we were going to do for starting time? I'm actually pretty flexible with start time, but yeah, like if we wanted to start the Zoom call again at 10:30 and then plan to get started again closer to 11.
Works for us.
Or did we say, sorry, or did we say 10 o'clock?
Even more previously, it said like 9:30, I think, schedule. You took like a polychronic approach, you know, it was like, made it very easy to show up on time in that sort of sense. But so anytime from, 10 to noon, I'll be here.
Yeah, it looks like the workshop part 2 we had scheduled. I'm just going off of what we had on the dev post. We had that one going from 9:30 to 11:30. So why don't we say that we can get this? Let's do it like a 10 to noon, and then maybe just get the Zoom call set up at 9:30. Then we don't necessarily have to take as much of a break for lunch. We can just kind of get wrapped up right before lunch if that works for everyone.
All right.
So we'll send out details on that this week as well. So we'll say to keep it as closer to the part 2 as we had posted, we'll say like 10 to noon, and then we'll have the Zoom set up a little earlier if people want to jump in. And that's on Halloween.
Yeah. Yes.
Justin, if you're still online, oh, there you are. Are they still doing the kid workshop IoT stuff, or did that get canceled too?
Yeah, we only had one person sign up, so and I reached out to that person and they haven't responded, so it remains to be seen.
Okay.
If we're still gonna do it, but if we do, okay, I'll certainly let people know. But yeah, that event is still out there.
Okay. So again, next week, October 31st, we'll start the Zoom call around 9:30-ish, 9:45, and then we'll get things kicked off at 10. And from, I'd say maybe 10 to 10:30, we would probably do some Q&A and talk through, anything that people built over the week. So I'd encourage all of you this week to, if you're familiar with some HTML, CSS, and JavaScript, go in and turn this into something of your own. And if you have any questions about issues that you run into, let me know, and I'll post some resources. I'll send out some resources on kind of an intro to JavaScript. And also by the end of the weekend, I'll set up like a Discord or a Slack channel that people can post questions to and share code, because, I think that one of the best ways to learn is to, help teach other people. And so anybody that can jump in and say, hey, this is what I'm stuck on, or hey, this is what I built. I'd love to see what everyone puts together for this. And then next week we'll dive into some of the server side stuff. And then, yeah.
You just reminded me, we could use the Applied AI Slack channel. I could post a link right now if anybody wants to join that as a sort of a place to communicate. Would that make sense over the next week?
Yeah. Yeah. I was thinking, initially for the IoT Hackday, Discord would be good, but if it's just
perfect,
if it's just
sure.
a workshop, there's no point in setting up a whole new thing. So yeah, I think Applied AI Slack channel would be a great spot for communication on this.
Okay, I'll just drop this in right now. Now anyone should be able to join the Applied AI Slack channel. Should I? And I guess the other question is I guess under the channels. I mean, we just have a general channel, but we could have a specific channel underneath there if you wanted.
Yeah, let's drop let's create a channel for the workshop.
What do you want to call it here?
We could just call it TensorFlow or machine learning. Make it general.
Okay, I'm creating it right now. I'll call it TensorFlow Workshop, dash workshop.
Awesome. And so if everybody that's interested wants to get set up on that Slack channel and post your ideas or your questions there, I'll be monitoring that throughout the week as well as my email. Don't feel like you have to stick to image classification. I mean, I think that that's the best. I think that what we did today is the best, like, ramp to learning this stuff. But if you want to try to, if you have the time and the interest and want to try to get into some of the other models for detecting different things, it would be really cool if people could share experiences on what they're working on or what they built or anything that you've got. Whether it's training a model to do the face mask detection or, doing something completely different.
Listening to a piano.
Yeah.
Like Yanni was saying. Maybe we'll have that solved by next Saturday.
All right. Any other final questions as we kind of wrap up for the day?
I'm having trouble finding the Slack channel. What's the name of the? I mean, I'm on the Slack channel, but did we open?
Yeah, there should be a new channel in there. I think if you're in the Slack, I don't know, can you press a plus button to add a channel to your list? Say browse channels.
And
then just type in start. Just type, or you should be able to scroll. Maybe find one's called TensorFlow Workshop.
Yep, found it now. Okay, so I have to do the join channel to get that. Okay, great.
Yeah, it's public, but I don't think I could add everyone instantaneously. So yeah, you'll have to just self-add yourself once you get into the Slack channel.
I got it. Thanks.
Yeah.
And yeah, I'm gonna work on my piano thingy. It's
cool.
All right, and then what I'm going to do, I can log in as well and just show people what that looks like if anyone's interested.
Right.
All right, add. Find your workspaces. Oh boy, all of the accounts and all the passwords. Okay, app find. Well, definitely thank you very much for everyone that attended this. This was, I think it turned out really well, and I'm really happy with. I think a lot of you just found out about it this week, and so I appreciate you taking the time to come out and learn something new on a Saturday. And I thought I had a lot of fun kind of going through all of this. So
thank you so much. It was awesome. I mean, this is really useful stuff.
Yeah, thank you.
Agreed.
Always great. Just being around smart people talking about smart stuff.
Yeah, it was awesome. Thank you so much.
Well, have a good weekend, everybody. This was great.
See you next week.
Definitely.
See you
Yeah,
guys.
for sure.
Thank you.
Bye, everybody. Thanks for coming out.
All right. Bye.
Bye.